Storage allocation space strategy. As we know that runtime memory is divided into 4 parts, they are code, static, stack, heap. A different storage allocation space is used by each data area that is in static, stack and heap. So the different storage allocation spaces are static allocation space, stack allocation space, heap allocation space. Next, static allocation space. The memory is allocated during compilation time. For normal variables and arrays, the memory is allocated during compilation time. As we know, static means fixed. So once the memory is allocated during compilation time, then it's impossible to change the size of the code during runtime. Next, drawbacks. We must know in advance the size of the array. Example, performing on 5 elements. So the size of the array should be a 5. If more memory is allocated than required, then memory is going to be wasted. For example, A of 100 is allocated. A of 5 is used. If less memory is allocated than required, then it causes a problem that is insufficient memory. For example, A of 5 is allocated but we need A of 10. Insertion and deletion operations are very expensive. Next, dynamic allocation strategy. The memory is allocated during runtime. There are 1. Stack allocation strategy. 2. Heap allocation strategy. Let's demonstrate accordingly. Stack allocation strategy. Stack is a data structure that works on the principle of LIFO. It stores the information of activation records. An activation record is pushed into the stack when activation begins and it is popped when activation ends. Limitations of stack allocation strategy. The size of the stack is limited depending on the operating system. Variables cannot be resized. Memory is allocated in a contiguous block. Contiguous means 2 things that are connected or touching along one side. For example, consider the Southern Ocean and Atlantic Ocean, they both are contiguous. Or, 2 states are contiguous with each other, but the laws are quite different and allocation and deallocation are automatically done by the compiler. Next, heap allocation strategy. It is the most flexible allocation scheme. Allocation deallocation of memory can be done at any time and any place depending upon users' requirements. It is used to allocate memory to the variable dynamically, and when the variables are no more used, then claim it back. It supports the recursion process. Here is the example for dynamic allocation. Next, access to non-local data on the stack. A non-local variable is a variable that is not locally defined in a procedure. The mechanism for finding data used within the procedure but does not belong to the procedure. Various conditions to accessing non-local data. They are: data access without nested procedures, issues with nested procedures, a language with nested procedure declaration, nesting depth, access links. Next, data access without nested procedures. Nested procedure function is a procedure that is defined with another function. Example: it is a function definition within which we are defining another function B. It is a function definition within this we are calling function C. It is a calling function. So here variables are defined either within a single function or outside any function. Global variables have a scope consisting of all functions, so they are allocated static storage. Next, issues with the nested procedure. Accessing the procedure declaration is more complicated, so it uses the normal static scoping rule. The nested declaration does not tell the relative position of activation records at runtime. Example: it is a function defined. Here it is a nested function. Next, nesting depth. For this, procedures without nested within another procedure, the nesting depth equals 1. Here is the example. Here the nested depth is 1. Next, access link. The implementation of a static scope rule for nested functions is obtained by adding a pointer called access link to each activation record. Example: for this, nesting depth is 1. For this, nesting depth is 2. So here, using the access link, the nested function Q is obtained from the implementation of the static scope rule. So, the P function obtains the Q function. Well, that's the end of today's topic. Along with the video explanations, we offer notes, mind maps, infographics and more to all the subjects from your syllabus. And also career guidance programs from current working IT professionals. And many more to our supporters. To join our supporters community, use the subscription link given below. For more topics from your syllabus, please visit our website given in the description. If you like the explanation, Press the like button and rate us from 1 to 5 in the comments section below. For getting updates on any video we posted, please subscribe to our channel and press the bell icon. We will be back with another concept soon.